research. So the presentation of today is about case study research in software engineering. My name is Michael Felderer. I'm a professor at the University of Innsbruck and a guest professor at the Blekinge Institute of Technology in Sweden. And I want to directly start with a motivation, right? When we think about empirical methods and research, then we often have the lab environments in mind, right? So if we want to study bacteria, then the lab environment is obviously the right way to go. So the proper place to study bacteria is in the laboratory and not in the jungle. But on the other hand, if we want to study the behavior and the social interaction maybe of elephants, then labs or even the zoo may not be the right place, right? So there is a nice quote on this stating that the proper place to study elephants is the jungle, not the zoo, so not the controlled environment. And this is what case study research is about. It's about studying phenomena in their real world, real life context, right? And we also see we have less control as in labs. That's the most obvious difference. So we don't have the human that controls something. We don't have the different controlled settings via these classes. We have really a real world context. And this is where case study research comes from. As we study the real life context, it comes more from the social sciences as a research method, not as experimentation, which obviously comes from the natural sciences. And well-renowned researcher in case study research that also wrote a well-cited and used book, Yin. He defines case study as an empirical inquiry that investigates a contemporary phenomenon within its real life context, especially when the boundaries between the phenomenon and the context are not clearly evident, right? So this is exactly the setting that we have for studying the elephants, right? We need to have them in the real world environment. And this for sure also holds for many topics that are closer to our field. For instance, if you want to study the adoption of ERP systems, so a classical topic in information systems, right? It may be hard to do that in an isolated lab environment. You really have to take the whole company environment into account. And this now brings us to software engineering, where case study research is also of high value. Yeah, and this has led, let's say about 10 years ago, that software engineering researchers, mainly Per Runeson from Lund University and colleagues, started to adopt case study research for software engineering purposes. And this even resulted in a book that is based on Yin's book that I showed before and adapts the methodology for software engineering. And this is also what will be the main content of my today's talk, to discuss with you case studies in software engineering. So what is a case study in software engineering? It's an empirical inquiry that draws on multiple sources of evidence. That's important, and we will see that several times. So we take not only data from quantitative data from one experiment, but we also try to complement with interviews, for instance, yeah, to investigate one special instance or a small number of instances, so like a project, a process, a specific software product of a contemporary software engineering phenomenon. So we are not interested in, let's say, the V model, yeah, but we are interested in a topic that is hot, that is important, where maybe not theories are available yet. At the moment, it could be DevOps as an example. Then in its real life context, so not in a lab environment, but really looking probably into DevOps pipelines in practice. And always the boundary between the phenomena and the context cannot clearly be specified. It's also important to make clear that case study research is a separate research strategy, because when you look into papers in the past, then you often see that researchers call an example in their paper also a case study. Yep. So I recommend to really differentiate this. Case study is an empirical inquiry that relies on multiple sources of evidence. So just let's say coming up with a new static analysis approach and just applying it on one toy example. This I would really call example and not a case study. For that, it would really need, in the sense of our definition, to have it in a real world context. When you apply the tool, for instance, in real world projects, then you could frame it as a case study. Okay, the main reference that I will use is this book by Per Runeson and colleagues on case study research that was published 2012 in Wiley. However, it's more or less an extended version of a core journal paper that is available open access by two of the authors of that book via Springer. So you can grab it from that link. It's open access. And it really is a very nice read on case study methodology in software engineering. It condenses the information and you can apply it right off the way. This is also how I started about, it was in 2011, 2012, when I did my first case study. I also took that journal paper and started right away, and it helped me really a lot to learn about the methodology and to apply it properly. Yeah, why do we have to investigate case studies in software engineering? Or let's say it differently, why do we need a special methodology for case studies in software engineering? Why not just take the approach of Yin right away? So case studies in software engineering have some specifics that even differentiate them from case studies in information systems, for instance. So the one thing is that we are in software engineering, we consider software processes and their improvement, and these are normally complex activities. So we really investigate software processes, which are complex, unique processes, not like business processes, manufacturing processes, which are repeated, let's say, very often and should be standardized as much as possible. Software development is a complex, somehow individualized activity. There are many influence factors. It can also not be studied fully in isolation, so you have to take the organizational context into account. And yes, it needs empirical studies in real-world settings, as also the human factors are a core contribution. It's not just the pure artifact analysis that helps us. Yes, furthermore, the software engineering also differs from the social sciences. I mean, where the case study methodology comes from. So it's more about software development, not the use of software, right? Information systems, you would, for instance, you investigate the use of ERP systems. In software engineering, you would consider their development. Yeah. We are more talking about project organizations and not so much about line or function oriented ones. It's always about advanced engineering and not routine work. And we also are interested in improving practice, not only in describing it, right? So in software engineering, we also always have the design-oriented perspective. We want to improve things. We want to create artifacts. So therefore, it makes sense to have a specific software engineering angle, viewpoint on case studies. Yes, do not make the presentation too dry. I want to present the methodology based on running examples. And I will take two case studies from my own research. And my own research is to a large extent on software quality testing and the link to requirements engineering. So these two case studies are from that area. The first one is about using defect taxonomies for testing requirements. So therefore, we linked requirements to defect taxonomies and used this joint information to derive more efficient and effective test cases. Yeah, I will also share the papers later with you, so you can then look into them. This was published in IEEE Software, so more than a practitioner-oriented venue. And the second case study is about risk orientation in software testing processes for small and medium enterprises. So there we investigate how the concept of risk is integrated in testing processes with special focus on small and medium enterprises. So there we investigate several companies. We do a multiple case study, as we will see later, and we also compare it to earlier results from large enterprises. This was published in the Software Quality Journal and is even a recommended case study in recent empirical guidelines by the ACM, which I will also mention later. Okay, these are my running examples, so you don't have to understand or get all the details. I will always just take some fragments out of them that you get a feeling for case study research. Okay, yeah, Booth. That's also just background. So these Booth case studies share a joint angle, namely that we have a test process starting with planning, designing of test cases, implementation of test cases, execution, evaluation, and they try to improve this test activity somehow, may it be via defect taxonomies or may it be via explicit risk profiles. More generally spoken, Booth approaches use a risk perspective to improve the phases of the test process. This is important from the perspective that I will later also mention some underlying theory, and therefore risk-based testing is well suited for that. Okay, so how can we, before we go into case study research in detail, how can we position case study research compared to other well-known research strategies? Yeah? So the most common research strategies in software engineering are doing experiments, right, or doing surveys. Experiments and surveys, they are fixed in the sense that you have a research design up front, you plan your experiment, you plan different treatments, right? And the same holds for a survey. You plan your questionnaire and then you put it online and then you run it, right? So the design is fixed, and case study is a little bit more flexible, and that it has in common with action research, which we consider closely related to case studies here for our purposes. There, the situation is a bit different in the sense that you for sure also have a research protocol that you want to apply, but you are flexible in the sense that when you actually go to a company, yeah, so it's also about doing hands-on research with real people. It may turn out that a new person pops up that you want to interview, or it may be the case that you find a new repository that you haven't thought of before that you can also use to extract data, right? And then you have to adapt your research plan, so it's flexible in that sense. And also the primary objective is normally different. Case studies are well applied when you want to explore things, so you want to investigate areas that you don't know. In our case, for instance, we didn't know how risk-based testing works in SMEs, so we explored it, right? Or you also want to improve something. This is when you also do your case study in the sense that you actively work with the team. So then you are in the borderline to action research. Surveys, on the other hand, their main objective is to describe situations, right? I mean, you want to do a survey about the application of agile methodologies, then you just, you take a sample of people and you interview them, or you do an online questionnaire, whatever, or in an experiment, you want to find out which factor can explain a specific behavior, right? Yes, in this sense, action research and case study, they are closely related as they are both flexible, yeah, and case studies can also have some improving elements. So we don't distinguish them sharply, but one aspect of more action research oriented case studies is that you explicitly interact with the people. You want to change something, you want to improve something. And another aspect that case studies and action research have in common is that the level of control is rather low. So you really go into the real world setting, right? And you want to explore something there, you want to improve something there, but you cannot exactly control the people then that you can ask, because you have the people that are in the company, the data is the company data that is there, right? In experiment in service, it's different. You can highly control your research setting by making it, on the other hand, less realistic. That's, on the other hand, the advantage also of case studies and action research, that you have a high level of realism, as artifacts are neither artificial nor isolated, as they are often have to be in experiments, right? If you want to do an experiment on test-driven development, this is also very, we have seen many experiments in the past, then it's very difficult to take a real world system to investigate test-driven development in a controlled setting, where you compare it to not doing test first to test last testing, because then you could not properly do it in a lab environment, because if a program is very complex, then there may be some unexpected things that then are again a co-founding factor for your experiment and so on, right? But in case studies, this is all these aspects from the real world are welcome, and you observe them, you take them into account. This gives this for sure more realism, but on the other hand, for sure, the explanatory power of case studies is lower, as you have as it's harder to create these chains of evidence, yeah, these concrete factors that influence the outcome. Okay, after this initial statements about case study research, let's actually do it. And for that, we need the research process for case studies. As all empirical studies, it starts with the design. You have to design your study, yeah. Then you have to collect data, you have to analyze it, and finally to report it. Yeah, I would say this process is also generic. You can put that also as a basis for experimentation or for surveys. You also have the same phases. But what is here specific to case studies and is these feedback loops, right? So in case study research, the design is to some extent flexible. This means when you find out new relevant questions or new relevant data sources, then you can adapt your research design. For sure, everything has to be well documented. So it should not be ad hoc. It should still stay a scientific investigation. Okay, let's start with design. So when you design a case study, then you have to take several aspects into account. For sure, as all empirical studies, you need to define objectives, at least an objective and clear research questions that help you to figure out what you want to achieve, what knowledge you want to gain, yeah, and what you actually want to discover. We will come to that in a second. Then there should be some kind of underlying theory. We will discuss that this is not easy in software engineering, as still it lacks theories, but there are pragmatic ways to deal with it. This is also something that is common in software engineering, that it's still a pragmatic discipline, also from its history. Yeah. Then you have to properly select cases. That's something that is unique to case study research. It's not about this, typically about this statistical sampling that you do in experiments or surveys, or should do in surveys and experiments, but it's really about selecting cases that have specific characteristics. Yeah, methods of data collection, methods of data analysis, and validity we will then discuss in this respective phases about data collection and analysis, and also validity. We will discuss there, but for sure this is already part of the design, because you should in principle be clear which data you want to collect and how you want to collect it and how you want to analyze it in principle. Yeah. Yes, let's start with the objective and research questions. I think this is something you're already familiar with in principle. So you define an objective that can be, for this example, that you want to investigate static analysis in practice, and then you define research questions, which can in principle be of 4 types: improving oriented, exploratory, explanatory, and descriptive. The first 2 are dominating normally in case studies, but let's look into an example for an improving oriented research question. It could, for instance, be how can static analysis be introduced to reduce the number of field defects. So you want to improve an existing process by introducing static analysis, and you want to investigate the effect on the number of defects that are then explored in the field. An exploratory question could look like, are static analysis tools used, and if yes, why? Yeah, so there you assume that you don't really know how static analysis is done in practice. Therefore, you look into cases, and you figure out how static analysis tools are used and for what purpose. Yeah, for sure, this assumes that you don't know a lot about the field. I mean, if you already know a lot about static analysis, then you could even think about doing a survey about this topic, right? But in order to be able to do a proper survey, you need some knowledge, and case studies can help you to get that initial knowledge. Then explanatory questions could look like, does the usage of static analysis tools reduce the number of field defects? You want to really investigate the cause-effect relationship between the application of static analysis tools and field defects. You may immediately get that this can become difficult for case study research, because if you investigate them in their environment, right, it's hard to isolate this influence that the static analysis tools have on the number of defects. I mean, you could then also ask, isn't the type of testing that I apply, or the initial quality, or the established process, or the product that I investigate, are not that influence factors, yeah, that somehow blur this influence that the static analysis tool has. Yeah, and finally, descriptive, about how is static analysis used in practice, could be such a question. Okay, these are research questions. You have to define some research questions for your setting, but let's come to concrete examples from my 2 case studies. So in the first one, about the introduction of defect taxonomies, to improve the effectiveness and efficiency of requirements-based testing, we had questions like, how can defect taxonomies be integrated into the system testing process? So this is really a clear improving oriented one. Do defect taxonomies improve effectiveness of system testing, or do defect taxonomies improve the efficiency of system testing? So this was really a case study where the improving aspects were the main focus. Yeah? And the case study 2 was the one on investigating the state of risk orientation, risk-based testing in testing processes of small and medium enterprises. There we had questions, how is software testing organized in SMEs? So an exploratory one. What is the role of risk in software testing of SMEs? Also that's exploratory. And the third one, what are the differences of risk-based testing in SMEs versus large enterprises? Yeah. So this, if you could introduce a separate category a comparative one, right? Or if you do it, you could even consider it as an explanatory if you have a quite controlled setting. But in our case, it was also an exploratory style, how we did it. Yeah, so these are research questions. So they form the basis, because you need research questions to properly actually conduct your research, right? Then already the formulation of the questions, but then the further design and execution of your research should be underpinned by a theory. Yeah. As far as I have seen, you already learned about theory and you know its importance. So I will not talk about theories in detail here, but theories are important to actually somehow judge the outcome of your studies and to put them into a bigger picture. And from a constructive perspective, for formulating research questions and how you measure things and so on, theories also provide you concepts and relationships between concepts. And that is also very important for case studies. I mean, their contribution to theories is anyway a special topic, but what is in any case important is that they provide theories provide concepts and relationships. But still, in software engineering, differing, for instance, from information systems, the use of theory is really very scarce. So we have rarely established theories that we can rely on. But Runeson and his colleagues provided suggestions how to deal with that situation. And ways to deal with it could be that you develop a grounded theory as a basis. Yeah, it provides you then with concepts. That's one way. Another one is to do a systematic literature review or a mapping study, because that also condenses concepts somehow. Yeah, and you can then, for instance, I could have done an initial systematic literature review on risk-based testing or on the application of defect taxonomies, and this already helps me to sharpen the concepts before I come up with a new approach or before I figure out what the test process should be and so on. And the third one, it's somehow linked, is the development of or the use of a conceptual framework or taxonomy. So this is what we did. We developed a taxonomy. It was based on a semi-structured literature review as well. And this taxonomy provided us the basic concepts. And as both the defect taxonomy related testing approach as also the risk-based testing approach are linked to risk-based testing, we could use it as a basis for both, right? So the taxonomy is as follows. We don't have to go into detail here, but it's a taxonomy of risk-based testing. It considers what are the drivers to do it. Then it has a branch that covers the risk assessment, how it is done, which elements are covered, which factors are considered to estimate the risk of specific components. And then we consider how risk aspects can be integrated into the different parts of the test process in the planning, design, implementation, execution, and evaluation. Yeah, for instance, as execution, you can order the test cases based on risk. This is a very basic example. That's very helpful. In my case, let's say I was already somehow very experienced with risk-based testing when I started doing the case studies. So I somehow had a taxonomy in mind, even if it's even if we would not have it formally published, although we did that. But if you enter an area where you want to do a case study and you are not, let's say you are not familiar with it when you start the research process, then this can be very helpful, that you try to find out taxonomies that provide you with a frame and the underlying concepts. Then you can formulate research questions, that you can figure out how to measure things, and so on. Which data you need to measure that. Yes, and then it comes to the cases that we want to investigate and the units of analysis. So a case, as the definition of case study research says, can be anything that is a contemporary SA phenomenon in its real life context. So that's a case, right? So that's a very broad definition, and we can refine that further in 2 dimensions. On the one hand, we can define within a case several units of analysis, and on the other hand, we can also take several cases. Yeah? So we have 2 dimensions to refine that, and I want to discuss this via examples. So first, what can in principle be a case or also a unit of analysis in software engineering? So a case can be an individual. So you want to investigate, for instance, onboarding, yeah, how to bring in new developers in teams, or whether testing is suitable for that. Then you could do such. You can consider an individual as case. You could investigate a group, yeah, a group of people, for instance, open source developers, right? That could be a group and something like that, or a team, yeah. Then processes like a test process, in my case, you could take projects, products, policies, specific roles, events that happen. So what is, for instance, the stand-ups, daily stand-ups, if you want to investigate that, or you can also take technologies. I mean, you could say you're interested in the role of cloud platforms for development, then this would be technology oriented. Yeah, so there is a large variety of what you can take as cases, and let's look into the cases in our setting, in the 2 case studies that I want to tell you about. So in the first case study, this was the case study about using defect taxonomies to improve requirements-based testing. We had 1 case, and this 1 case was the test process of a health insurance institution. So we improved the testing in a health insurance institution, and their test process was our case, and we took 2 units of analysis, and these were 2 projects, so 2 extensions of their software that were conducted in 2 different projects, right? And they were the 2 projects were based on the principle same test process, and in one case we integrated our new defect taxonomy approach, and in the other setting not. And the cases were carefully selected because the characteristics are similar size, similar amount of people involved, yeah, similar number of iterations, and so on. So this is a setting where we have 1 case, and in this case we have 2 units of analysis, 2 units where we actually grab the data from. In the second case study, the cases were 5 SMEs, and so we have a so-called multiple case study because we have 5 cases, and these case studies to some extent are holistic because within the case we didn't define explicit units of analysis. So we just took the companies as cases, right? And therefore it fits here in this upper right, multiple case, but not explicit units of analysis. So they are somehow the case themselves. Yeah, and we extracted data here, and so we had let's say the cases were selected, so number of employees and the core business, the domain, and the actual process, how it is applied. And the cases were also somehow selected in the sense that we have different domains, then some development that is more embedded, other that is more agile, right? So really also do so more web development with agile. The embedded one is more traditional waterfall oriented. So really to get a broad range of cases from SMEs, right? Do not get a too narrow focused perspective. Yes, and that leads us to strategies for selecting cases. So you should, if you have the chance, I mean, sometimes you are in a relationship with a company and you cannot freely select the case for sure. The same for sure was the case in our setting to some extent. So the cases can be selected according to different characteristics. In the first setting, yeah, we were more oriented towards having similar characteristics and different just in the test process. In the second one, we wanted to have a maximum variation, so having more embedded, but web development, more waterfall oriented, more agile, to have this maximum variety. Then other strategies can be you want to get extreme deviant cases, yeah, that can be also very helpful if you want to investigate onboarding. Yeah, then you may take very agile or very waterfall-oriented, really extreme cases could be helpful to find out aspects there. So that's important to take into account here, that you should carefully select it, and the selection is a key factor in the research process. And then when you designed your case study properly, so defined the questions, then the underlying theory or framework, then also the cases have been selected, and you also defined which data to collect and how to analyze it. Yeah, then all these aspects should be condensed in a protocol. I mean, for sure, you should start writing the protocol from the very beginning. So everything that I said should already be part of a protocol. And this protocol should also come up with tactical aspects like the schedule when you want to do something. So the protocol in this sense is really some kind of a written project plan. So that really guides you through your case study. It's different from the report. The report then is not so much about the project plan in sense of schedule and potential risks that can happen and so on. It's then really more about writing the methodology that you applied, and then the results, their interpretation, and things like that. Yeah. Then some other aspects that you should take into account and that are important. These are aspects of integrity. So be aware that you have to go into companies, you have to work with companies, you will get data from them, and therefore you need some informed consent. Yeah, you have to tell the people what you want to do, what you need from them, what may happen with the data. So for sure, also confidentiality is important. Then you should, you may take into account how to handle sensitive results. Yeah, if the output is that people have not done something they should have done, so you find out they haven't tested properly as they should have done. Yeah, how to deal with such situations. So that's really important. Then also getting feedback from the people. So take into account that these integrity issues, mainly to legal, ethical, or professional aspects, have to be carefully touched, and everything that you can clarify up front here helps a lot. Yeah, also so you should get the commitment that you can publish, and who should be the co-author from the company, and so on, how to deal with all that aspects that should be clarified up front. But this is more research management, and I also don't want to go into details here now. Okay, now let's continue with the collection of the information. So you designed your case study, and now you collect your data in the organization. And there we have to be aware that in case studies differing from experiments, or grounded theory, we consider both quantitative data and qualitative data. As I think you already learned about the qualitative approaches a lot, I don't have to explain you the differences. You are familiar with it. I mean, quantitative is more about numbers and values, and qualitative more about existence and frequency of words or other objects like images and so on. Yeah, in quantitative, it's more about measuring, and in qualitative data about collecting, coding, structuring information, and in quantitative you apply statistical analysis. And the thing with case study research is that we value both data to the same extent. So we don't have a clear focus on quantitative or qualitative data. In software engineering. I mean, there are other disciplines where the focus is more towards qualitative data, I would say, but in software engineering, it's really both. And to see that it's both, we can see the so-called types of data sources, which are naturally linked to quantitative or qualitative data to some extent. We can distinguish first, second, and third degree data sources. So first degree data sources are those where we directly involve people. What does this mean? This is linked to the instruments of doing interviews with people or questionnaires or even focus groups, right? Where you really directly involve people. The second degree data sources are where you indirectly involve people. So that could be that you observe people, so you watch them doing their meetings, or you could also instrument systems. I mean, this is, for instance, when you have continuous integration, right? Then you can lock systems easily, and you can see whether static analysis has an effect or something like that. And the third degree, this is when you study work artifacts only. So this is where humans are not involved explicitly anymore, but you mine repositories. So for instance, you take open source projects or you take the Git repositories in the company and analyze that, or you analyze also documentation. I mean, probably you have meeting protocols and you analyze that data. So the thing also again with case studies, that's the message. You should always use all, if possible, data sources on all levels, but at least at different levels. So not just taking one data source, but taking multiple data sources and triangulate them. Triangulation, so putting things together in a triangle. That's an essential aspect of case studies. Multiple data sources are not something that harms you because you get a different angle, but this is something that you should value and that brings you additional insights, right? So here you see this qualitative analysis nature of case studies, that you really integrate data from different data sources. Yeah, also in our two examples, we did that. So in both case studies, we had data sources on all degrees. So in the first one, the defect taxonomy, we did open interviews with testers, requirements engineers, managers. Then we did observations via the involved test manager. So there the setting was that we had one test manager in the company who actually wanted to work with us and improve something. This is the one pattern that leads to success, having one person in the organization in the cases that wants to work with you. And in the other setting, in the case study 2, we had a funded project, and in the funded project, the 5 companies were involved. Yeah, in third degree, we collected test data, defect data, requirements data, effort data, and analyzed that properly. Yeah, in the second case, we did semi-structured. So interviews with the CEO, project managers. We also had a questionnaire. We observed the processes via discussion with the people involved in the project, with the 5 company people involved in the project. And as a third degree source, we collected also data from tests, defects, requirements, and designs. So for instance, we investigated the defect databases like Jira or the test management tool to extract test data and so on. But I don't want to go into details here. That is what I wanted to say regarding the collection. And then it comes to the analysis of data. Also here, I guess you learned a lot about the basics already. You can in principle do quantitative and qualitative analysis. Optimally, again, in case studies, you do both, and they are linked to your data. I mean, if you do interviews, then this is more a basis for qualitative analysis. And if you contain defect data, then this is more a basis for doing a quantitative analysis. I think that's also clear. Quantitative analysis from a pragmatic perspective, this is where graphical methods and statistical methods help a lot. Yeah, and in qualitative analysis, it's the analysis of unstructured data that you code and group, and then draw conclusions from it. So let me just give you a few examples of the types of analysis that we did in the 2 case studies. So in the first case study, where we had the 2 units of analysis, right? We collected data from the 2 units of analysis from project A, project B, yeah, and we even computed metrics like the number of tests that we developed in relation to the number of use cases and requirements we had, or the number of failures that we observed per test case, and we compared them, yeah, in the setting with defect taxonomies and without. Then, so this is a descriptive statistics, because I mean we describe the project. So this is just plain measuring of values, and then we could also do some inductive statistics. So we could collect the effort data for the module, for the effort data for the tests in the case of application of defect taxonomies and not doing defect taxonomies. So here we see an excerpt of that data, and then we could really do a statistical test, yeah, that measures whether the effort when applying defect taxonomies for creating the test case is significantly lower than when not doing defect taxonomies, not applying defect taxonomy. So there we could really do some hypothesis testing, so already a more advanced statistical analysis, right? Then in the second case study, we could do some kind of a visual analysis that you can see here. There we investigated this integration of risk-based testing into test processes. I mean, we defined a risk-based testing process with 7 steps, right? And here you see the 5 cases. And then we asked the companies with respect to their perceived ease of use of integrating risk and the usefulness of these steps. And you can see here the different radar charts for showing for each step in the process how useful it was on a scale from very low to very high for each of the 5 companies. And you can interpret this. So for instance, this was very interesting that one aspect was low and we digged deeper. Yeah, so just that you see, you can do some visual analysis, whatever that is in your setting. And then here, the last analysis is a classical qualitative analysis. So we analyzed what we got from the interviews of the people, and we investigated how the risk consideration had a main focus on business risks or project risks. And we found that in 4 of the 5 case companies, right? So we didn't ask them directly. So we asked them how you actually measure your risks, right? And from what they told us, whether they said, oh, we take the complexity of components into account, and this would be a technical aspect, or whether they just said, yes, for us counts how critical something is for the customer, then this would be a risk, business risk. So, and we tried to investigate this so-called chain of evidence. This is how it's called, from what we got in the interviews to these concrete findings. Yeah, and when we found that one of the cases supported this, then we made a plus here, and if not, then we made a minus. We further then had previous data from large enterprises. It's also I want to call it a comparative analysis. There we, for instance, found that the risks are mainly focused on taking the product risks into account, but not so much the project risks. So we found here that the situation in SMEs and in large enterprises is different. Yeah? Sometimes we made smaller here because we found that how risks are measured is less precise in the SMEs than it is in the large enterprises with separate test departments. So we had a smaller here. And for some statements, we found similar results. So that the test risk is considered in all testing activities. We found that in the large enterprises and in our 5 case SMEs. So here we have an equal symbol. Okay, and then that's the types of analysis that you can do, for sure, depending on the data you have, on the setting you have. And then it comes to validity. That's a very important aspect that you should consider from the very beginning. Whenever you do empirical research, then you have to think about the validity or trustworthiness of the results, yeah? And to what extent your results are biased, and to take measures to reduce these threats, to reduce potential threats to validity as much as possible in all phases of your study. And based on the Yin categorization, Runeson and his colleagues in the book defined 4 types of validity that you actually should take into account. And this is construct validity, internal validity, external validity, and reliability. And this can be seen as a checklist, yeah, to actually think about what potential threats to validity do you have, and how can you mitigate them to reduce that they harm your results to much as possible. Let's browse through these 4 types of validity. So let's start with the construct validity. Construct validity is about the extent that your operational measures are really study what you want or what the company that you investigate have in mind. So really whether what you measure, what you actually investigate, is linked to the underlying constructs, therefore construct validity. An example could be that what risk-based testing means, yeah, what the concept of risk-based testing is, in each of the 4 cases could differ. So when I ask them, the companies, about risk-based testing, they may tell me or may talk about completely different things because they mean something different. This is a potential threat here. And ways to deal with it are to integrate multiple data sources, or to link the concepts that I ask in my questions to, for instance, the risk-based testing taxonomy that I showed you. Yeah, so these are ways to deal with it, but also to have a feedback loop with the key informants that provided you data, so then you can be sure whether you meant the same thing when you compiled the data. That's a way to deal with that. Internal validity is a concern when you investigate causal relationships. When you want to investigate whether factors influence other factors, then there may be this internal to your analysis, this threats to internal validity. An example in our setting could be the causal relationship between the application of defect taxonomies for testing and the number of test cases and failures might be influenced by other factors, like the effort that is investigated in testing and so on, the maturity of the product. And in order to mitigate that, we tried to control or make these two projects as comparable as possible by giving them the same characteristics. That was one way to deal with this threat to internal validity in our setting. External validity is about generalization. Yeah, so it's about to what extent can my results be generalized to other contexts outside of the case that I actually investigated. So an example here could be the risk concept applied in SME cases might not be generalizable to arbitrary SMEs. Ways to deal with that is really to try to get a broad range of cases as we did, right? To carefully select them and to replicate such studies. That are ways to deal with that. And finally, reliability. This is about to what extent the data and analysis are dependent on the specific researchers. So as case studies have a flexible research design, yeah, reliability is an issue. So the question is there, would another researcher find the same results as I do? How can you deal with that? So you can deal with that by having a clear protocol and also by let's say, monitoring the different aspects, for instance, in a case study. Yeah, so that's a general threat that you have in case studies. And in our case, it could have been that the approach about doing defect taxonomies depends on the researcher. We tried to define the approach properly that everyone else can conduct as well. Data collection and analysis procedures were documented and the data properly provided. Yes, and then you can apply general principles to improve validity. You can the triangulation helps a lot, yeah. So, and it also helps to have long-term relationships with companies. So if you already know the companies, then there is also a lower chance of misunderstanding each other about concepts. Then doing research as a team, right? Doing case studies not as a one-person team, but as a team of researchers. Then also investigating negative cases, yeah, extreme cases that can help you to challenge your chains of evidence, and doing audit trails. So always keep track of data, yeah, in a systematic way. And as I said, triangulation is a core aspect of case study research. Always triangulate things, and triangulation in the narrower sense means that you triangulate the data sources, first, second, third level sources, if you can remember, but also you can do the observer triangulation. This is somehow a different word for doing research in a team, yeah. So having several people that observe, analyze data, methodological triangulation by combining different ways of collecting, analyzing data, quantitative, qualitative approaches, for instance, and theory triangulation, having different underlying theories, if possible, different viewpoints can also help. This is somehow linked to, yes, having also extreme border cases. So triangulation is let's say, an umbrella, yeah, for properly dealing and reducing threats to validity. That's the message here. Okay, and finally, we come to the reporting. So that's the last aspect that I want to do very shortly only, because you also hear a lot about writing anyway in this course, and in principle, writing case studies is not much different. You can write them down in a classical linear analytic structure of a research report. So where you have the introduction with the problem statement, research objectives, context, and related work, where you have earlier work, potential theories, then you have the whole design of your study, then the results, and finally the conclusion. Yeah. What is also important for case studies, and maybe a bit different, for instance, when you do a theoretical experiment, is that case studies are done in a real life contemporary setting. So the results should normally also be relevant to practitioners. This means that your target audience may not only be researchers, yeah, but also practitioners. So for instance, our first case study on defect taxonomies was also published in IEEE Software, which is more a practitioner-oriented magazine. Also, it has also a high impact factor, so it also counts for you as a researcher. But there the writing style is a bit different, right? There the methodological parts have to be condensed, so practitioners are more pragmatic in the sense they're interested in the results and how can the results help me to improve my situation, right? So what could work here, for instance, that you make the methodology short and even put the whole protocol online so that someone who is really interested can get it. But focus more on the results and the impact, maybe one aspect. And finally, recently new empirical standards from ACM SIGSOFT were published, and there's also a category about case studies, and the second case study that I presented to you about this risk orientation SMEs is one recommended study as a good example for how this can be properly done and reported. And there you find hints when you do a case study or when you review a case study. It's also guidelines for reviewers, what is essential to be reported, what is desirable, and what is extraordinary. Yeah. I don't want to dig here into details, but there are standards, and you can also see the reference here. And this already leads me to the final references. These are the studies that we did, the book, then also the journal article by Runeson that is available open access, and finally also these empirical standards from ACM SIGSOFT. With that, I'm at the end of my presentation. Many thanks for your attention, and now I'm for sure open for questions.